In this video, we're going to look at special products of binomials. So what we're going to do is take a look at two different patterns. So the first pattern we're going to look at is the square of a binomial pattern. We'll do two examples to see if we can come up with an overall pattern that happens, kind of like a shortcut that we can use whenever we see a square of a binomial. Okay, so what we're going to do is we're just going to use the distributive property here instead of the grid method to do x plus 3 times x plus 3, because that's the same thing as x plus 3 squared. Again, using the distribution method, we're doing first term times each of the second polynomial terms. So x times x is x squared, and then x times 3 is 3x, and that was both positive. Then we're going to take the second term and multiply it by each of the terms in the second polynomial. So 3 times x, again, gets me 3x, and then 3 times 3 gets me 9. So if I go ahead and combine like terms here to simplify, I add the positive 3x and the positive 3x, I end up getting x squared plus 6x plus 9. Okay, let's look at one with subtraction. So I've got x minus 2 times x minus 2. Again, using the distribution method, I take the first term in the first polynomial, multiply it by both terms in the second. So I get x squared and then minus 2x. Then I take the second term in the first and multiply it by both terms in the second. Remember, this is a negative 2. So negative 2 times x is negative 2x, and negative 2 times negative 2 is positive 4. Then we look at combining like terms, and we end up getting x squared minus 4x plus 4. Okay, so if I'm taking a look at this, what I can summarize for the pattern is that I'm going to square the first term and the last term of the original. So x squared gets me this x squared here. 3 squared gets me this 9 here. So let me do that in pink so you guys can see that. So this first part, squaring the first and last term. So if I square this guy, I get x squared. If I square 3, I get 9. If I square this guy, I get x squared. If I square negative 2, I get positive 4. Okay, so the note that they're always going to be positive does work. Okay. The next thing is that we're going to write the product of both the terms. So the terms are x and 3. The product of those is 3x. And we're going to do this twice. Well, that's exactly what I did here. So if I take this part, it said write the product of both terms. So both terms were x and positive 3. The product of those two is 3x. And we wrote them twice right here when I combined like terms. And I put them in the middle of my squares. Okay, let's see if I did it over here. I've got x and negative 2. The product of those is negative 2x. I wrote them twice in the middle of my squares. Okay, so that means that the pattern does work. So let's talk about what it would look like for a shortcut. If I am following the first part where I square the first and the last terms in a general setting like a plus b squared, I'm going to have a squared in the front and b squared in the back, both of them positive. Same thing over here, they're always positive, so I'm going to have a squared in the front and b squared in the back. And then the middle part says write the product of both of the terms, do it twice. So again, I have a, b, and a, b. They're both positive. When I write them twice, I'm going to put them in the middle after I combine them. So combining those like terms, I'm going to have plus 2ab. So this would be the shortcut. You don't have to do the distribution property. You can just square both terms and then put their product times 2 in the middle. So let's do that over here. Their product of a times negative b is negative ab. If I do that twice, I have negative 2ab, and then my b squared was positive. So the only thing that changes with subtraction is your product in the middle is negative instead of positive. Okay, that's the first special case. So the second special case that we're going to take a look at is the sum and difference pattern. Okay, so let's take a look at two examples for the sum and difference pattern. So again, we're going to use distributive property and see what happens. Let's take my first term x and multiply it by both terms in the second polynomial. So I've got x times x, which is x squared, x times negative 2, which is negative 2x. Then the second term, 2 times x and 2 times negative 2. So 2 times x is 2x, and 2 times negative 2 is negative 4. So then let's look at combining like terms. I can combine negative 2x and positive 2x. Those get 0x, which is just nothing. So I don't write any x's. I bring down the x squared and the minus 4, and that would be the solution to my original multiplication. All right, let's take a look at the next one. We've got x times x and x times negative 6. So that's x squared minus 6x. Then we have 6 times x and 6 times negative 6. So we've got plus 6x minus 36. I combine like terms and I get x squared. This is plus a 0x because those eliminate, and then minus 36. Okay, so what I'm noticing in my pattern is that I square the first and the last terms. This time they're not all going to be positive. So I squared x and got x squared. I squared the 2's and I get 4. Okay, and I'm subtracting the new terms. So the x squared and the 4, because the middle disappears. So I'm taking x and squaring it, and 6 and squaring it, and then I subtract the 2 squares. Okay, so the subtraction is what goes in the middle. Okay, which means when I have something like a plus b times a minus b, I'm going to square the a and get a squared, square the b and get b squared, and then I'm going to subtract those terms because their products eliminate. Okay, so anytime you have or you recognize one of the special binomial times binomials, so either a binomial squared or a binomial that's multiplied by itself, except for one has a sum and one has a difference, you can use those patterns instead of the distribution method or the grid method.